Hello, I would like to now present the outcome of an event that was organized after the IRCOBI conference this year. EU Project Virtual has been organizing events in conjunction with IRCOBI for the last few years. And for this year, we organized an online hackathon where HBM users were introduced to the open access VIVA Plus models being developed in the virtual project and other tools for HBMs used in the VIVA Plus open science ecosystem. Today, we're going to see two HBM applications that were explored by the hackathon participants. First, Manuel Valdano will present a simulation of VIVA Plus on an e-scooter. And second, team of Johnny Gensel and Konstantin Pietro will present a rear impact simulation on a lab seat. These are preliminary results, simulations that the participants tried out during the limited time available to them during the hackathon. Today's presenters also win a scholarship from Project Virtual to attend IRCOBI conference next year. Congratulations to Manuel, Johnny, and Konstantin. Now to their presentations.
Hi everyone, I'm going to show you the e-scooter rider application of the VIVA Plus model. As you can see here, we use the standing female 50 percentile VIVA Plus model, and we joined this model with an e-scooter developed in the university. So the first task was to posture the model. For this, we used the marionette method using the landmark extracted from VIVA. Once the model was postured, we carry out two simulations. So you can see here the first one. In this case, the e-scooter hits the edge of the sidewalk at 16 kilometers per hour. And at the bottom, you can see the head acceleration, which reached around 800 Gs. Okay, this resulted in a Hig 15 equal to around 7,000. To soften the impact, we include a helmet in the second model. The helmet is from Biocore. The model is the 2016 Rydell Speed Classic. And you can see at the right-hand side of the slide, the result of this simulation. As you can see, the kinematics of both simulations are really close. And at the bottom, you can see the results of the second simulation. In this case, the head acceleration and Hig 15 were reduced, but this reduction was not expected as the chin impacted the ground directly in both cases. So this is all. Thank you for your attention and the space to show you the results so far.
Our title is Rear Impact Simulations for VIVA Plus 50F and 50M on the Chalmers laboratory seat. We have looked at an earlier publication by Anna Karlsson, where she investigated different head restraint distances of a volunteer setup. We tried to replicate that in the virtual environment. This is our simulation results with the VIVA Plus 50 male version and the simulation with 50F, the female version. My colleague Konstantin will go through the dinosaur evaluation.
Thank you, Johnny. As Johnny told us, we evaluated our post-processed with dinosaur. As you can see on the left side, we have the head X acceleration of our simulation. And on the other side, we have the volunteer data. We can see that the curve has a similar shape from our simulation and the volunteer data. The peak of the volunteer data is a lot higher, but that's because there is a contact between head of the occupant and the head restraint. And in our simulation environment, we didn't have this contact. Below, we have the X displacement of the head. Again, our results against the volunteer data, and we also have a similar shape. Our goal here was just to try out all the twos and get plausible result as we see here. The next steps will be, for example, to add a belt pretensioner, so we also have a plausible rebound phase, and decrease the head-to-head rest distance so we can see or evaluate the head accelerations or other injury criteria. Thank you for listening and thanks for the attention.